As we have already learned in our previous lectures, a set or space design is an expression that involves the audience interest and provokes them to find links with the text situation or play rather than merely presenting the visual literally. We had already had a glimpse of the history of theatre architecture and the principles and approach to designing a set. But in order to materialize a visual concept or idea into a physical space, one is required to do some paperwork. This paperwork is actually a set of technical drawings that constitute the basic idea of space drawn to scale. This serves as the basic communication between the designer and the executioner. These need to be executed with utmost care and measured accuracy. Technical drawings have their own vocabulary constituting of lines and other symbols. These symbols are universally agreed upon and recognized. Although the measuring unit might change depending upon the place, area or country, in India, the usually accepted measuring unit is feet and inches. The measurements in feet that need to be put on papers are represented by inches. Drawings can be made by hand or with a computer. Hand drafting involves the use of drafting equipment such as the T-square, triangles, compass, rulers, etc. Whereas for computer drafting, there are a number of good drafting softwares available in the market. In this lecture, I shall be introducing you to the concept and kinds of technical drawings, throwing light upon their function and significance in set building. But before we start, let me acquaint you with the stage divisions, followed almost universally everywhere. A stage can be divided into 9 parts, and each part has been given a name specifying the location. This helps in directing as well as communicating. These are stage right, center stage and stage left. Assuming the left and right orientation of direction from a person standing on the stage facing the audience. After understanding the basics of stage division, let me now begin by telling you the difference between two-dimensional and three-dimensional drawings. For this, we shall have to understand the concept of space with reference to the coordinate system. In order to communicate an idea of matter in a space, one needs to measure it on the basis of some parameters. These parameters can be broken down into 3 axes, namely the x, y and z axis. They have both positive as well as negative values, depending upon the direction. While the area shared by the x and the y axis is known as the xy plane, the area shared between the y and the z axis is known as the yz plane, and so on. We can also say that here the x, y and z axis signify the length, breadth and height of an object respectively. Thus, a matter can be represented in space with the help of these axes. 3D means three-dimensional. Three-dimensional refers to the number of axes running from an origin point. Like 2D has 2 axes, x and y, that are running from one origin. 3D has 3 axes, x, y and z, which run from its own origin point. The most visible difference between 2D and 3D is a 2D drawing is flat, whereas a 3D drawing stands out from the page. This is because the z-axis has added a perspective angle to the drawing. Let us take a look at the 3D model of the block. Here, Side 1 represents the front view of the block. This is known as the front elevation, whereas side 2 represents the side elevation of the block, and side 3 represents the top view, that is known as the ground plan of the block in the technical terminology. That was a simple example of how a piece of block can be represented on paper, both in a three-dimensional as well as two-dimensional grammar. But not all requirements are so simple. This means that when one is dealing with sets, one needs to keep in mind that there can be several elements present which together form the set. The technical drawings might be more elaborate with a number of elements together, yet they will always be based on the same principles. Now, in order to develop an understanding of these drawings, we need to acquaint ourselves with its basic vocabulary or the tools of set designing. The set designer has two different sets of tools. The first set constitutes of the aesthetic elements of visual composition. This is similar to those of other visual artists. The other tools are the practical objects used to create stage environments. While almost anything can be put into a stage setting, in practical terms, the same basic structures are used over and over again. Let's discuss about the aesthetic tools first. Line. The dominant lines of a composition might be vertical, horizontal, diagonal, curved or spiral. Line itself may dominate the composition or only define the edges of masses. Mass, that is the size of the elements on the stage. On stage, any element's mass design should be in relevance with the actor's body. Composition. This aspect is concerned about the arrangement of the scenic elements arranged in space along any given axis. The composition might be symmetrical, balanced or unbalanced. Space. This can be broken down into two. Positive space is three-dimensional space taken up by scenic objects, whereas negative space is open space, which may be taken up by actors or perhaps by movement of actors and other pieces of scenery. Texture. This can be both two-dimensional as well as three-dimensional. Two-dimensional texture is variation in color, pattern and material. Three-dimensional texture is a tactile property. Objects could be rough, smooth, silky, etc. Color. This again has four properties: hue, saturation, value and temperature. These elements are distinct in personality but interdependent in features. However, we shall not be discussing in detail about these in this lecture. All of these aesthetic tools will have metaphorical and emotional qualities for an audience member. These associations are generally culturally relative. In other words, they are not innate but learned. Nevertheless, they can be put to use by a designer who wants his set to have a specific emotional impact on an audience. Now, let's get down to the practical tools. Flats. These are used to make two-dimensional structures. They are usually constructed of canvas stretched over a wooden frame. Walls, whether interior or exterior, are often built from flats, which are then painted and textured to resemble a real building material or interior decoration. Often flats are used together by hinging them or lashing them. They are often anchored to the stage floor with stage braces. Platforms and stairs. These are used to add levels to the stage. whether a few steps up into another room of a house, or a second story to a building, or a higher level representing a different location. Cyclorama. This is a large white canvas or plaster structure along the back of the stage. Apart from these, there might be various other tools applied to break down the idea or concept into comprehensible, pragmatic elements for physical metamorphosis. These will be entirely subjective to every play. It is not a necessity to use platforms, stairs, or flats in set design for every kind of play. However, here in this lecture, we shall be sticking to these only, as it would help clarify the concept of technical drawings in the most competent manner. Let us now acquaint ourselves with the basic symbols that might be used for drawings. Look at this drawing. As we can see here, various symbols used to communicate various elements. For example, a straight line can represent a flat. A plain line accompanied with a stretch of dotted lines can be said to be representing an arc. If there are doors, we need to specify the direction of this swing by marking it with an arrow. Similarly, one can see there are separate styles of representing various kinds of doors and windows. Also, look at the rectangular figure with a number marked inside a circle. The rectangular figure represents a platform, whereas the figure inside the circle indicates the height of that particular platform. For representing a staircase with regular or irregular tread, we draw small rectangular blocks equivalent to the number of steps in actual model, specifying their individual heights and marking them in a circle. Now, let's come down to the topic of technical drawings in detail. As we have already discussed, the major set of drawings that are required for any set construction are basic sketches, ground plan, front elevation, and side elevation. As we have learned in previous lectures, a sketch is a rough draft of the set design visualized by a designer. It is free of any measurements, however, the aesthetical proportions are kept intact. This is a sketch of the play Jamunia, directed and designed by Professor Robin Das, staged at the CD Fort Auditorium. Let us now learn about the concept and execution of a ground plan. A ground plan, often denoted as GP in working language, can be said to be the bird's eye view of the stage. This is the top view drawing of a set in 2 dimension. That is, a measured marking of the space only on the x and the y axis. The z axis, that is, the height, is not shown in the drawing. It is only mentioned on the drawing in numbers with a plus sign if the height falls in the positive z-axis, that is above the neutral stage level, whereas a negative sign if the object is below the neutral stage height, measuring the depth. Let us take a look at the ground plan of the same play. As we can infer from the marking at the corner, the drawing has been drawn to the scale of 1 inch is to 10 feet. The second information that we can gather from the diagram is which side is the audience sitting. Observe the various platforms, ramps, stairs represented by their treads, the free acting area in front that can be seen. This is how the set shall look from the top. All perspective lines have been removed. The whole drawing is only in 2-dimensional in order to communicate the idea with clarity. We can also see the angles marked to specify the exact measurements of angular shapes and placements. The length and breadth of each object on the stage is drawn to scale here, with markings specifying their exact measurements. However, height or the z-axis is completely eliminated. The heights are merely mentioned on the objects within a circle with a plus or minus sign indicating their height or depth in numbers, not visually. For example, let us take the center platform for reference. As we can infer from the figure, the length and breadth of the block is 16 inches and 12 inches respectively, while the height is mentioned within the small square in the platform, which says plus 6 inches. This means that the height of the platform is 6 inches. An important thing here to remember is that the measurements of the heights in the blocks are the actual heights and not in reduced scale. We can also see the height of each rise from the drawings of the staircase behind. The ground plan is often accompanied with notes by the designer to clarify or explain anything in further details. Thus, my friends, that's how we can understand, interpret and represent a drawing from the top angle. This drawing is extremely important as it plays a vital role for all other departments, especially the light designer, for planning the position of the lights. Coming on to the concept and execution of the front elevation drawing of a set. An elevation is a term drawn from architecture referring to drawings of the walls as if facing them, in effect elevating the ground plan into the third dimension. Elevations become the framework for detail drawings, painters' elevations and construction drawings. Elevations show either the front, back or side view of a particular portion of the ground plan, elevating it into a straight, flattened out, full-face drawing without perspective. Let us take a look at the front elevation drawing of the same set. Front elevations are scaled mechanical drawings showing the front views of all the scenery. The setting is flattened out and each visible surface is drawn in a single plane. As we can observe, this is how the set shall appear from the front, minus the perspectives. Here we see a detailed illustration based on the measurements provided in the ground plan of the same plane. Also, the long vertical rectangles at both the corners represent the flats on each side of the stage. Elevations may even include window draperies, wall hangings, set dressings and furniture or objects placed on or against the walls. The scenic designer also provides painters' elevations. These drawings are scaled front elevations rendered in color to aid scenic artists in the layout and painting of the scenery. They include the proportions, colors, appropriate highlight and shadow tones, wallpaper designs, cartooning and ornamentations. Let us now understand the concept of side elevation drawings. As you can remember from the block example above, the side elevation is the two-dimensional drawing showing the details of either sides of an object or set. For example, let us consider the side elevation of the same set. Here we can see a detailed illustration of the stage right side elevation. The 5 vertical lines are the flats considered on both the sides, whereas we can see the staircase, the ramps and small technical details that were not specified in the ground plan earlier. Imagine now that we slice the same set into 2 halves with a sharp knife. Then the two-dimensional drawing of each internal side drawn to scale shall be known as the cross-section. It is just like the side elevation as far as the process of drafting is concerned. Let us now take a look at the final model of the set. This has been raised only on the basis of the details provided by the ground plan, front elevation and side elevation. We can now see the raised platforms, the stairs, the flats and ramps in complete form. This is how the front elevation would look like as extracted by the 3D model, while this is the side elevation of the stage left. A model also plays an important role in the set building, as it helps communicating the idea even to those who are unfamiliar to the technical terminology of drawings. Anybody can comprehend the idea of the design after taking a look at the 3D model. Hence, they are useful in visualizing the composition of the scenic design and its relationship with the theatre space and audience. Thus, with this, we come to an end to today's lecture. But before we end, I would like to thank my friend and colleague Prashant Parmar for providing us with the sketches, technical drawings as well as 3D model to be used as reference for the lecture. I hope you enjoyed today's lecture. Remember, these drawings can be fun once you understand their basic concept and grasp the process of execution. So, gather all your tools and start decodifying the matter around you. There is no limit to explore space, for the entire universe is your stage. Good luck and goodbye.